Hurry up, Joshua. Joshua, please leave your bag of drugs on the back, thanks. It really looks like a drug bag. This is like a picture of Dr. Rain, Breaking Bad. You're in on something, aren't you?
How many pages will this lesson take?
It's not true.
Just learn about they have left.
3 pages. Happy to please. Okay. So, last time we were having a look at dot product. So we're going to look at why dot product is something useful for us. So here's the problem we're dealing with. We have 2 vectors, position vectors, OA, and let's say then OB. And we'd like to know the angle between the vectors. So this could be in 3 dimensions. You know, you could have like one vector here and then one vector here, and you want the angle between them if they made a triangle. So what we're going to do is we're going to work out a formula to find this angle. So the only things we know are the A and the B. So we know what the vector A is and we know what the vector B is. So I need to just give them names. So I can say, for example, here, A equals, we'll just say A1, A2, A3 to make it easy, and B equals B1, B2, B3, just to make it easy. So, it is possible to know what this vector is that completes the triangle. This is the vector AB. So the vector AB is B minus A, so that would be B1 minus A1, B2 minus A2, B3 minus A3. Now this is important because if we know the A, the B and the AB, that means we could know what the magnitude of A is, the magnitude of B is, and the magnitude of AB. These are all things we can know because we know A and B. That's good because we can use the cosine rule from semester 1 to find the angle here. So the cosine rule says that AB squared equals A squared plus B squared minus twice A magnitude B cos theta. So this is really good because we know the magnitudes here. But we can simplify this formula. Okay. I'll need to scroll down now in a second. Okay, can I scroll down a little bit? So we can simplify this a bit. We can say that if I take this one over to the left and this one over to the right, I can end up getting cos theta equals magnitude of A squared plus magnitude of B squared, and then divided by 2 magnitude of A, magnitude of B. That's it, isn't it? Now just remember magnitude of A squared, if you remember from the last class. That's right, isn't it? No, I've done... No, sorry, I've left out an AB.
Yeah, AB.
A magnitude squared plus B magnitude squared minus AB squared all over 2AB. Now, yeah, I'm taking this one here over to the left and taking this one here over to the right, and then I'll divide by this. So on the top, A squared is just A dot A, and this is B dot B. We did this last time. So we can on the top have A dot A plus B dot B minus AB dot AB all over 2 magnitude A magnitude B. Okay, so let's start putting in terms here. So cos theta equals A1 squared plus A2 squared plus A3 squared plus B1 squared plus B2 squared plus B3 squared minus B1 minus A1 squared plus B2 minus A2 squared plus B3 minus A3 squared all over 2 square root A1 squared plus, you know what, I'm just going to leave it for the moment as 2AB. Okay, now on the top we can expand, so we get cos theta equals A1 squared plus A2 squared plus A3 squared plus B1 squared plus B2 squared plus B3 squared minus B1 squared plus 2A1B1 minus A1 squared plus B2 squared, sorry, sorry, just so it's not clear, I should have had big brackets here as well because of that. Okay, so let me just make a little bit more space. Minus A1 squared. Okay, now on to the next one. Minus B2 squared plus 2A2B2 minus A2 squared. If I zoom out again, can you still see? Okay. I'll just go on the next line. Minus B3 squared plus 2A3B3 minus A3 squared all over 2A times B. Now the great thing here is a lot of stuff cancels on the top, a whole lot of stuff cancels on the top. So A1 squared goes with minus A1 squared, A2 squared goes with minus A2 squared, A3 squared goes with minus A3 squared, B1 squared goes with minus B1 squared, B2 squared with minus B2 squared, B3 squared with minus B3 squared. I'm only left with 1, 2, 3 terms. So on the top I get cos theta equals 2 A1B1 plus 2 A2B2 plus 2 A3B3 all over 2 magnitude A magnitude B. Now something else cancels. What's in common here? The 2's. So you get cos theta equals A1B1 plus A2B2 plus A3B3 all over magnitude of A times magnitude of B. But the top line should look familiar. What's the numerator here? Come on, it looks very familiar. The top line is what?
Line Z.
Alright? Come on. What's the top line here? What? I think I heard someone say it. This is, I know most people right now are thinking, Easter, holiday. Is this your last class?
Yes.
Just those losers have to stay longer. Come on guys, what's the top line here? I just said it 4 seconds ago. What's the top line here? I know what it is.
Yeah.
Somebody tell me.
Give us a hint.
It possibly was done in, let me see, the last class?
Wait, don't say it. Don't say it.
I think.
What is it? Thank you. It is, on the top, it is A dot with B. Remember that?
Yeah,
Magnitude of A multiply magnitude of B. Yep. In fact, if you wanted to, you could simplify this. Listen. If you wanted to, you could simplify this any more. This is usually how it is in the formula book. But, as you saw, this here is a unit vector of A, and then what's this one? Unit vector of B. So you can even simplify it more. You could actually say cos theta is A as a unit vector dot with B as a unit vector. What's that? This is what the proof has been leading to, yes. But I'm just saying this is usually how it is in the formula book, but in fact this explains why the dot product was important in the last class, because in fact if you had unit vectors, the dot product of unit vectors gives you the cos of the angle between the vectors. You know how to make unit vectors. You divide by the magnitude, and you know how to dot. So, doing this lets you find the angle between the vectors. So let's do an example. Okay, can I scroll down? Yes, you have this? Yeah. Right, let's have a look at an example. So first let's just do one in 2 dimensions. So here's the vector 3i plus 4j. And then here's the vector here 5i plus 12j. Now we want the angle between them. So we know that cos theta is equal to A dot B as unit vectors. So that would be 15 plus, try again, 48, all over square root 169 square root 25. Yeah, so on the top we have 63, isn't it? Yes? Do we have 63 on the top? Yes, and on the bottom we have 65. So that means cos theta equals 63 over 65. So theta equals cos inverse 63 over 65, which is what, about 5 degrees or something? People with calculators, give me the angle. This is right, isn't it? Did I do this right? What is it? 14. 0.125?
0.25.
25. But there's actually two answers here. Remember, a second answer when you're doing cos is, what is it? Well, actually, there's a second answer here, not because you're doing cos inverse. If I just go to the side for one moment, just for one moment, if I draw two lines and ask you for the angle between them, there's actually two answers really, because I'm not being clear if I mean this angle between the two lines or maybe I mean this other angle here. But anyways, in the exam they will ask for either the acute or the obtuse angle. Usually they want the acute. But if they wanted the obtuse angle, which would be, let me see if I just extend my vector here, that would be this bigger angle here. That would be 180 minus 14.25, if they wanted that. Okay, I'll give you one to try now in 3 dimensions. Can I scroll down?
Yes.
Yep. So we have one vector here, and then we have another vector here, and this is in 3 dimensions. Oops. So this one here will say 1, 2, 1, and then this one here will say 5, 2, 1. So give me the angle they make, please. The acute angle. So close. So close. Have an answer yet? Not yet? Okay, so let's have a look here. On the top we dot, so that's 5 plus 4 plus 1, all over magnitude of 30, is it? Magnitude of 6. Right, so that's 10 over, this would be 6 root 5, is it? No, anyways, it doesn't matter. It'd be root 180.
6 root 5.
It is 6 root 5, alright. Which is 10 over 6 root 5, which would be 5 over 3 root 5. So if I do cos inverse of that, or if you want, it's cos inverse root 5 over 3, it's the same thing as that, isn't it? It's cos inverse root 5 over 3. So what's that? 41.81. What did you get, Joshua? What? Really? I thought you said it was 60 something. Oh, you did a 180, the minus. Anyway, it's a straightforward calculation. And again, the section A question. Now, I just need to go back to the formula for a moment and point out one important, and it turns out to be very important for some section B questions, one important condition here. This will not work when what happens? This is not going to work if what? Come on, you're doing that thing where you pretend you don't know what I'm talking about and you don't understand, but we've done this before with formulas. This formula will not work if what? The magnitude of A is 0 or the magnitude of B is 0. That's actually important, very important. So we cannot use this formula if the vectors have magnitude 0. Okay? Right, and there's another important application now which we'll look at. So if I have two vectors, often I would like to know if they are perpendicular or not. So that means I want to know if theta equals 90 or not. So I'll put a little question mark here. So then that means I want to know if cos theta is equal to, what's cos 90? Yeah. So I want to know if cos theta is 0 or not. But how can I calculate cos theta? Well, that's just A dot B over magnitude of A times magnitude of B. I want to know if that's equal to 0. So there's only one part I need to check here. Do I care about the bottom? No, because this will be 0 if what? If the top is 0. And it won't be 0 if the top is not 0. Therefore, you end up with this result. If A is perpendicular to B, then that will mean A dot B is to equal 0. But what's great is that the reverse is true as well, of course. If A dot B is equal to 0, then that means A is perpendicular to B. So we end up with this one convenient result. A dot B is equal to 0 if and only if they are perpendicular. So if they're perpendicular, they must have a dot product of 0, and if their dot product is 0, then they must be perpendicular. But don't forget, this is all true as long as you're not doing anything silly like having 0 vectors. So as long as the vectors are not 0, then the dot product provides us a very convenient way to check if two vectors are perpendicular. Something again which is a section A question.
Given the magnitudes are not 0.
Sorry, yeah. Well, the only way that the magnitudes could be 0 is if the three parts of the vector was 0. So, yeah, it's the same meaning. Like, the only way a vector could have no length if it was 0, 0, 0. Okay, so this is an important result of dot products here. That A dot B is 0 if and only if they are perpendicular. Okay. So I'll scroll down. Do you have this results written down? You have it, yeah? So I'll give you two vectors and I want you to work out if they're perpendicular or not. So vector A is 2, 1, 0, and then vector B is 1, minus 2, 5. So tell me if they're perpendicular or not. They are perpendicular. A dot B equals 2 minus 2 plus 0, which equals 0. So therefore, A is perpendicular to B. Okay. Find X so that x1, 2 is perpendicular to 3, 4, 1. So I want you to try this for me. Find x, the value of x that makes these vectors perpendicular. 3, 4, 1. Yeah. So if these are to be perpendicular, it means the dot product should be 0. So that means 3x plus 4 plus 2 should equal 0. So that means 3x should equal minus 6. So that means x should equal minus 2. If x is not minus 2, then they are definitely not perpendicular, and if x here is minus 2, then they are perpendicular. Okay, let me give you another one here, but maybe not quite as short. Find x so that the angle between x12 and 341 is 45 degrees. So this time I want you to find x that makes these vectors at an angle 45. Yep. You have it done yet? So let's have a look at it. So what you want here is cos 45 should equal 3x plus 4 plus 2 all over magnitude of x squared plus 1 plus 4 magnitude 26. Is that right? People with calculators, is that right? Thank you. So what's cos 45 is 1 over root 2, or you can root 2 over 2 is the other way to write it. So 1 over root 2 is equal to 3x plus 4 all over square root x squared plus 5 square root 26. What should I do next here? Well, I could cross multiply and square, or square and cross multiply. So I'll cross multiply first. I get root x squared plus 5 root 26 equals root 2 3x plus 4. Where's the plus 2? Oh! This should be a 6 here then, is it? 6 and 6. Thank you. Now I'll square everything. So I then get x squared plus 5 times 26 equals 2 times 9x squared plus 36x plus 36. So I get x squared plus 5 times 13 equals 9x squared plus 36x plus 36. So that's 13x squared minus 9x squared is 4x squared. 13 by 5 is 65. 65 minus 36 is 29. So there's a 29 at the end here. And then a minus 36x equal to 0. I picked this at random, so I really doubt that this has roots. So I have x equals minus b plus or minus the square root of b squared. No roots? No roots? No, these roots, sorry. B squared, what's 36 squared? 36 squared, please? 1296 minus 4ac all over 2a. So anyways, you're saying that's two roots, yeah? What are the two roots? 9, well, give it to me as a decimal, it's okay.
8.1.
Yeah? Or 0.89. Why are there two answers? Well, if I scroll down for a moment, one way you can think about it is if I say draw a vector that's 45 degrees to this. Yeah, like for example here, let me just draw a line with that. Suppose let's just make it 2 dimensions to make it easy. So let's say I say something like vector A is x1 and then vector B is 2, 3. So if I draw that, so there's B, and A is x1. So I don't know what the horizontal is, but I know its height is 1. So I have to draw my vector going up to 1. And I want to make it 45 degrees. So in fact, if I do it like this, then its height is 1 and its base is a small value of x, isn't it? But there's another way I could do it. I could kind of go 45 degrees down. No, I can't. I still need to go up to 1. So I could go really far out, but still go up to 1. So if I did something, well, it's not going to be quite right here. But if I did something like this, I could get a 45 that way. And I still have the height of 1 because I need 1 here. Anyway, that's a silly example, but the point of my silly example is to show you that there's two answers because your vector can probably make 45 degrees lying on one side or lying on the other side. So that's why there's two answers. So, and in fact, it's a little bit like the example I drew down below. One answer is really small and one answer is really big. Okay, so we can make two possible answers here. Okay, one more example now, which I'll let you try. Yeah. Which way do we do our x, y, z? I say that most books have the z going up, and the x is the one coming towards you, yeah. So I'll do my very best to go 3 dimensions here. Okay. Okay. And this one here is x. No, it's not. This one's x, y, and z. So I would just need to wait for Joshua because he feels he is so important that he can hold me up here. Joshua? Which statement is right now? You feel you're so important you can hold me up, or you're sorry that you were talking? See, I know you're smart. You made the right choice there. Good man. Okay. So what I'm doing here is I'm going to give you 3 points in 3 dimensions. So here, for example, is A, here, for example, is B, and here, for example, is C. And these 3 points, you can join them together to make a triangle. And what I'm doing is I'm giving you the vectors to each point. So in black here, there's vector A, OA. Then there's vector B. And then there's vector C. So these 3 vectors point to ABC as normal, but I'm just saying that you can join their endpoints to make a triangle. So I'm telling you that A, we'll say, is 1, 1, 1. B is 1, 2, 1. Make that clearer. B is 1, 2, 1. And then C is 2, 3, 4. So my first question here is, what is the angle between this vector AC and this vector AB? So firstly, what's this angle? So how could we get this? I'll let you do it, but maybe someone can give us the idea to start. What do we do? I want this angle here. So what's our formula for angle? We know it, don't we? Cos theta equals dot over magnitude. So my question is really, what vectors should we use in this formula? AC and AB. Do you know what AC is? No. Do you know A?
Yes.
Do you know C?
Yes.
Do you know the triangle rule? So first you have to find AC. Then you have to find AB. AC is C minus A and AB is B minus A. And then once you have that, you're finished. You just put them into your formula. So I'll give you a minute to get the angle for me. Yes? The one that I drew on the diagram that's in front of you. This angle right here. We'll call it angle J for Joshua. This helps you, Joshua? Yeah. So give me angle J, please. Okay, let's have a look at this one here. So first we need AC. So AC is C minus A, which would be 1, 2, and 3. And then we need AB, which is B minus A, which would be 0, 1, 0. So then cos J equals these two dotted together, which is 0 plus 2 plus 0, over magnitude 14, magnitude 1. So can we do cos inverse this number, please? We get J equals cos inverse 2 over root 14. 57.68. 58. Okay, so what I want you to do next now is get me this angle here, J2. So get me this angle now. So I want J2, please. So you do it exactly the same way, except this time it's CA and CB. Okay, does anyone have the J2 yet? Is that yes? What did you get? So 15 then, if I do 1 degree, yeah? Okay, finally, J3.
Can we just make 100 into 9?
Nope. I want you to do it using the dot product. The reason, Tanish, is because, you know, it could be an exam question where they say, calculate the 3 angles and show that the total is 180. Yeah. Mm-hmm. No. What you got? 107 is right, because you can check since they should total 180. I've seen this question a couple of times in section A and section B. They would give you a triangle and then ask you for one of the angles. Also, what they have done is ask you for one of the sides. So for example, they could ask you, how big is it from B to C? So we won't do it, but just tell me what I would need to do. What would I need to do to get the length from B to C? No. Magnitude of what vector? BC. And which is, what's BC? C minus B. Oh look, we'll do it now anyways. So it's magnitude of C minus B, which is 1, 1, 3. Yeah? Yes. Which is magnitude 11. Sorry, root 11. Huh? Because I said in the exam they might ask you for one of the angles or one of the sides. So I just did one as an example. Here. Part 1, part 2. Okay, right? Just do that little example at the end. The length of the side BC. Do you want a practice test after Easter? So I will wait maybe until vectors are finished, so then that means you can do 5 from 6 possibly in section B. Because we only have one chapter left after this, the statistics. And how many lessons are left in vectors, by the way? 3? Great, okay, so we'll do those 3 after Easter, and then the last, how do our classes, is the last class a double or a single in the week? This is normally the last class, which is the single. So we might have to wait until the next double class to do a practice test, okay? Alright, enjoy your holiday. Don't forget to do some study, I suppose.